So before we get started, just remember that this might be a hard topic to grasp and it'll take some time. So don't worry too much. Just practice. You'll get it. So far we've talked about an abstract class. An abstract class, we said it was kind of like a half concrete class where you could define fields and define methods, and half interface, which is all abstraction, such as you say abstract void something, which enforces any derived class to implement that method. Now, in both cases of abstract interface, you cannot create that object. The difference between an abstract interface would be that interface is more towards enforcing some actions to be built. And remember, actions for us is methods, right? So I'm enforcing that these methods are defined by whoever implements this interface. On the case of abstract, we could do that, but abstract is more about inheritance. So we're extending this class, which some methods are implemented and some methods are not. Some fields are given to us. In the case of interface, there is nothing implemented. Let me just type this out. This was a long thing to type. So nothing is implemented, and it's our job of whoever is implementing this interface to implement, to define the body of all those abstract methods. Now, why would you ever use an interface and why would you ever use an abstract? Just remember, well, I'll give you a good example and then we'll go a bit more in details. Just remember that an interface is more like having some common actions. A good example of this would be, okay, so a good example of this, we had person, right? We saw it in multiple videos when we were learning inheritance and so forth, so on. And inside person, there is a lot of things that we inherit, such as first name, etc., such as the method, the action, talk. Okay, and in this case, we could override it or etc. And we didn't want person to be created as an object. We wanted a more specific object created. So we made person abstract. So now we couldn't create an instance of person. We couldn't do new, right? This is not allowed for person. But any derived class is allowed, such as, let's say, teacher. They're allowed. And if there's any method that's set to abstract, we'll have to implement those methods. We had also students. And, you know, there's a lot of other stuff that could be person, such as, I don't know, police officer, as an example. Such as doctor, and so forth, so on. Right? We're inheriting some functionalities, some fields, and sometimes we're overriding those functionalities, and sometimes we are forced to define those functionalities. In the case of an interface, we're not talking about inheriting something. We're talking about more implementing something. Again, sorry for using the word something too much. So what I mean by that is, let's create an interface called annoying. Right? In the case of annoying, it's an action, let's say. It's an action that any type of object could have. Right? They don't have to be a person to be annoying. They could be a police officer, which could implement annoying. It could be a bug, you know, a little fly that's annoying. It could be the TV that's annoying. So you could see here, annoying doesn't really belong to anything, to any specific object, but all of those specified objects, police officer, fly, the TV, the you know, let's say some motorcycles that are just too loud and you're trying to be quiet, etc. These have the action of being annoying, right? So these could implement the interface annoying. Right? So you got to take it you got to think of it kind of like that. And again, it goes a bit deeper than this. And so now knowing that this is more like actions and not inheriting attributes and becoming part of that object. Again, don't forget the keyword is a will still work here. So police officer is annoying. Doctor is annoying, and so forth, so on. The same way we could say police officer is a person. Doctor is a person. Okay? So that still stands. Now, the bigger thing that you'll notice, we're giving actions, and we're going to do it in the later videos nonstop. We're going to implement this. The second big thing to note about this, let me erase a little bit on my screen. The second big thing to note about this, let me actually clear a lot of this. Second big thing to note about this is we talked about inheritance before, and we said we're only allowed one inheritance. So we're only allowed to extend one class. And this is important. When we extend a class, we're inheriting all functionalities possible. So this becomes problematic when we have a class. This becomes problematic if we try to extend two classes which have the same method. So let me think about this. I'm going to pause for a second to think about a good example. All right, I got a good example. It's okay example, okay, but it's going to work for us. So let's say we have an abstract class called animal. And in this case, it has a function or method predefined. Predefined. Breathe. And inside this method breathe, we'll breathe through nostrils. Okay? Then we have another class, and this one's called, let's say, fish. And again, it could be abstract or not, doesn't really matter. And inside of that, it also has breathe. And again, this time it's defined, but it's defined by fins. Now, let's suppose we have a hybrid of animal and fish, is both of them. So I don't know which one could be considered both. This is not a good literal example, so there's a lot of fault in that. But the point being, let's say, as an example, let's say platypus or something. If you don't know what a platypus is, so this is a platypus. It's kind of like a fish, animal, whatever you want to call it, okay? So platypus. Let's go back. So having this platypus, am I recording? Yes, I am. Okay, having this platypus, lost my pen. There we go. Okay, sorry about that. So having this platypus, okay, I don't know how to spell it. I just saw it too. Platypus. Yeah, okay, this is perfect. So having this platypus, and we make it inherit from fish and from animal, what happens is now platypus has an inherited method called breath, right? But the problem comes down to this method breath is defined in two places. The compiler needs to know which one does it execute when that platypus.breath is called. So when that method is called, which one of these would it execute? This is why you cannot do double inheritance or more inheritance than one from two classes. You could create a chain inheritance, meaning that there's a grandfather, father, and so forth, so on. But you cannot have, let's say, two grandfathers, as an example. You cannot inherit from your father and mother at the same time. Because if they both defined a method, the compiler wouldn't know which one to take. However, what if these two classes were actually interfaces? So this is an interface, and this is an interface. And we said an interface does not implement any methods. It can't have any fields, any methods implemented. It's all abstract. So basically, it's a contract. It's basically saying whoever takes this interface, whoever wants to, let's say, inherit, they have to implement these methods themselves. So there is no body, there's just breath, colon. There is no body, there's just breath, colon. Now, platypus, which, let's say, inherits from these two interface, will need to implement the body themselves. Now, this functions, this is correct, this works because these animal and fish, they just say what the method name is and what the method signature is. There is no collision because platypus, when it implements it, there is only one implementation. There is only one body. So even though both animal and fish are saying we have a method called breath and you need to implement it, there is actually only one implementation of it. There is only one definition of it, only one body of this method breath. And because of that, we could do multiple interfaces. We could inherit from multiple interfaces. Now, I hope that makes sense. We're going to practice it. Let's go over some rules that interfaces have. And you know what? We could probably even type that out so it's a bit better. So some rules that interfaces have, I'm going to just make this all comments so it doesn't give me red squigglies everywhere. So some rules that interfaces have, well, one, you cannot have any implementation of any sort. So no implementation basically means no body, no fields, almost no nothing, okay? The only thing is we're going to have abstract methods. Basically methods that you need to implement. Methods that you need to implement. And this is important. What else? So you could think of an interface as a contract, and this is important to remember. We're giving actions to whoever implements this interface. So again, remember that a knowing is not really an object. A knowing is more like something that an object could be doing. Many objects could be doing that. A mosquito, let's say a mosquito, a loud car, and this friend of yours. They're all annoying. What else do they have in common? Nothing much. They're just really, really annoying. So this would be a interface. It will be a great example because they're all annoying. They all will implement annoyance, but none of them would be that object. There's no specific objects to them. So we could have multiple inheritance. So multiple inheritance of interfaces. A concrete class could inherit multiple interfaces, but an interface class could only inherit interfaces. It cannot extend any abstract classes. Any concrete or abstract classes. This is important to note. An abstract class could extend a normal class, a concrete or abstract class, and it could implement as many interfaces as you want. And you're going to see that a lot happening. Actually, if we go and navigate, let's go have a little bit of fun. Let's say we'll start with this action performed. This whole action listener is itself an interface, right? The only rule it says is whoever wants this click to happen, they need to implement action listener, which enforces action perform being defined, right? Over here, action perform is not defined. We'll talk about this a little bit more. Over here, they're using some design pattern called the listener design pattern, or also called the observer design pattern. We'll come back to that. Sorry, my mouth is really dry. So this is an example of it. Let's go up. Let's say this JFrame, if we click on it, you'll notice that it extends one class called frame. So it's getting all those functionalities from frame, but it implements multiple interfaces. In this case, 1, 2, 3, 4. What are these interfaces? Well, we got Windows constant. We could read what it does. It's a few, in this case, there is nothing in there other than the static final. We're allowed to do that in the interface. Accessible. Now we have to implement this method called get accessible context. We could see it defined. Well, there's a lot of variations, but if we scroll down, or actually, you know what? Let's do structures here. We could see get accessible. It's not alphabetical. Let's do it alphabetical. Get accessible context. You see here it's being defined. Right? There's a lot of this going on. Let's go back down. And my computer froze. Okay, there we go. So back to here. We got root pane container. Again, we need to implement get root pane. We need to implement set content pane. We need to implement get content pane, etc., etc. Why? Well, because there is a lot of methods that would be calling those where I don't know it's JFrame, but you could see it's being utilized a lot of times. So again, we could only extend one class, but we could implement many contracts, many interfaces. Now, the same thing goes with these interfaces. So you'll notice some of them, well, none of them here, but you'll notice some of them will extend other interfaces. But can I see this one? None of the examples here. We're going to build some of these in the next coming videos. I hope it kind of gives you an idea what's going on. Soonish, we're going to talk about this add action listener. See you guys in the next video.